Hello everyone, here is a question based on Lewis structure. According to Lewis theory, the total number of sigma bond pairs and lone pairs of electrons around the central atom of perxenate ion is how many? We have XeO6 4 minus, we call this as perxenate anion, or simply perxenate is also okay. Now let us count the valence electrons in total. We have 8 valence electrons in xenon, isn't it? Because the 5s2 and 5p6 are the valence electrons. Atomic number of xenon is 54. Therefore, the electronic configuration is krypton, that has 36 electrons, and then 4d10, 5s2, 5p6. These are the valence electrons. The 5s2 and 5p6 are the valence electrons. So that's why I wrote 8. And then oxygen atomic number is 8. We are ignoring the 1s2 core. We have 6 oxygen atoms. Therefore, 6 times 6. And then for the 4 minus charge, we have to put 4 electrons. Therefore, this is equal to 8 plus 36 plus 4. Therefore, 48 valence electrons we have in total. Now using 48 valence electrons, let's write the Lewis structure of perxenate anion. Xenon comes at the center, and then let's make one bond pair with each oxygen atom. In that way, we would utilize 12 valence electrons. Now if we put 3 lone pairs around each oxygen, then basically we have accounted for all the valence electrons, isn't it? Because each oxygen atom satisfies the octet configuration. So 6 times 8, that is 48. Therefore, we have accounted for all the valence electrons. So let's calculate the formal charge. The question is this the best Lewis structure? Actually, it is not. Because if we calculate the formal charge for this, formal charge is equal to number of valence electrons minus number of non-bonded electrons, that is lone pairs of electrons, minus number of bond pairs by 2. So therefore, for xenon, this is equal to 8 minus 0 minus, we have 6 bond pairs. So therefore 12 by 2. Therefore, this is equal to 8 minus 6. So plus 2. Xenon will have a formal charge of plus 2. If we calculate for oxygen, then it would be 6 minus 6, because we have 3 lone pairs, and then 1 bond, so 2 by 2. So therefore, this will be equal to minus 1. So each oxygen will have a formal charge of minus 1. Now for the best Lewis structure, the formal charges should be minimized, isn't it? This structure is kind of a trap for Lewis structure, because we might think that plus 2 minus 6 is equal to minus 4, therefore this is the best Lewis structure. No, it is not. It is actually not. We have to minimize the formal charge for the central atom. Therefore, let's bring 2 lone pairs to the bond pairs. If we do that, then we would be making double bonds with the 2 oxygen atoms, and then single bond with the 4 oxygen atoms. So now if we calculate the formal charge for xenon, then it would be 0, isn't it? So let's say we have the best Lewis structure. If we calculate the formal charge now for xenon, then this is equal to 8 minus, we have no lone pairs once again, minus how many bonds we have? 4 plus 4, we have 8 bonds. Therefore 16 by 2, which means this is equal to 0. So the formal charge of xenon is 0. Likewise, if we calculate the formal charge for this oxygen atom, it would be 0. For this oxygen also it will be 0. And then for the rest of the 4 oxygen atoms, it would be minus 1. So therefore, this is the best Lewis structure for XeO6 4 minus, or the perxenate anion. So, how many sigma bonds we have? 6, isn't it? We have 6 sigma bonds plus 2 pi bonds, no lone pairs. Therefore, the correct answer here is 6, because they are asking the total number of sigma bond pairs. We don't have any lone pair. Therefore, 6 is the correct answer for this question.